Okay, so section 3.3, I can get more tools to come up. Okay, so now let's talk about subtraction, different subtraction models. So we're going to talk through all the different algorithms for subtraction. Takeaway model, number line model, those are two of the main models. And then the missing add-in model is kind of like when you're thinking about subtraction as just another form of addition. Some of you may have heard it as fact families when we were growing up. So here's the takeaway model. Say a student has unifix cubes or something like that, and you're like, okay, here we have 8 blocks, and we're going to take away 3 blocks. How many do we have left? And so that's called the takeaway model. Another way that's really fun to do that, using a 10 frame, well, that's the 10 frame. I'm sharing some things off script here just because I have some experience doing this actually with my own children. Um, so if you had a 10 frame like this and you get little Play-Doh balls and you count them down, so you're like, okay, I have 1, 2, 3, 4, 5, 6, 7, 8. And so imagine if you had the 8 Play-Doh balls and then you tell them to smush down 3. So then they're going to smush down 3 and they're going to be like, okay, how many do I have that are not smushed down? And you can see that you have 5. Or you could do it fun with like little goldfish or other teddy bear counters and minutes of this. So take away visually, you have this amount to begin with, you take away these, how many do you have left? The other way, the other model is the number line model. I don't really actually like the way they illustrated the number line model here, but essentially the way that I've explained it to my students is, sorry, this is really lagged and delayed today. Okay. Sorry, this is acting really strange. Okay, number line model. Um, so I prefer, instead of doing it like that, to do it like this. If you have 5, I'm trying to do 5 minus 3. Okay. And I have 3. I asked them how far apart are they on the number line. So how far apart, how much bigger is 5 than 3? That's the idea of difference, right? Because really subtraction is also just difference. So difference, if you have to find the difference versus find the sum, the difference would be like how far apart these numbers differ. And they differ by 2. So I prefer to illustrate it like that. And missing add-in model. So this is basically, if you just think about, if you know your facts really well, your addition facts, then you can just think about addition, rearrange as subtraction. So if you know, and something that I've done with students before is Post-it notes, and I don't know for sure if I can find them or grab and show you, but if you imagine like physical Post-it notes written down, and then you would like switch them around so they can see the relationship between so if you imagine that you have 3 Post-it notes, right? At first you have part, so you have whole, and then you have part and part. And so they can see, oh, 8 minus 5 is 3, or 8 minus 3 is 5, or you have the parts that equal the whole, and they can switch these in either order, and they can see that family there. So another way of thinking about subtraction is like, what do you need to add to get to 8? So I'm at 3, how many more do I need to get to 8? And it helps again if you have a good sense, a number sense where you know that 8 is 5 and 3. So this is more of the same. This is the idea of a unique whole number, just like it is for addition, basically that there's only one number where a minus b is equal to that number. Comparison model as another way to describe it. So if you're going to compare, instead of taking away, you line them up and you're like, okay, if I have 8 blocks here, and I have 3 blocks here, how many more? That concept of how many more, that is something that for solving word problems and knowing that that means to just subtract. It can be shown that if A is less than B, then A minus B is not meaningful in the set of whole numbers. So basically, you cannot take away a bigger number from a smaller number, unless we're talking about negative numbers. Sentences such as 9 plus 5 equals sun and 12 minus diamond equals 4 can be true or false depending on the values of the sun and the diamond. For example, if the sun is 10, then 9 plus 5 equals 10 is false. If the diamond is 8, then 12 minus 8 is true. The subtraction model, if you're going to model again with base 10 blocks and you're going to show 243, here's that model with this is 100, this is 100, and then you have 4 10s and then you have 3 1s, right? And so if you want to remove 6 logs on 1 unit, we can do that. We can take away 1, and then I'd have 2 left here. And then can I take away 6 here? I cannot. So what you do is you have to come over here and trade this out for 10 of these. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. They can physically do this with motives, but 100 block, 100 is the same as 10 10s. And now we have 14 10s, and I can take away 6. 1, 2, 3, 4, 5, 6. How many do I have left? 1, 2, 3, 4, 5, 6, 7, 8. And then you would just have 100 here. So you can visually describe what's going on in the typical subtraction algorithm. That's what we just showed. This is just saying if I add equal add-ins to both terms. So if I say I'm going to add 7 to both of these, 262 minus 170, then I can say 262 plus, or I can add bigger numbers, 30, 30, then I have 292 minus 200 is 92. So you can change things. If you change them equally, you're going to get the same answer. So this 292 minus 200 is the same as 255 minus 163 because you increased both of the numbers by the same amount. This is just talking about how you can make change easier. So say I want to do 100 minus 31. I actually like to think about this as a number line. So we're at 31 here. Here's 30. So 30, 40, 50, 60, 70, 80, 90, 100. And I'm trying to get to 100, right? So the difference here is how far apart they are. So you can do one of two things. They're showing count to 40 first. So if I need to count to 40, I'm going to count a 9 here. And then how many 10s do you have? 1, 2, 3, 4, 5, 6. Because you know 6 and 4 makes 10. So you have 69 is the combined difference. Or what I would probably tell a student is 31 is actually pretty close to 30, right? And how do I get from 30 to 100? Well, that's 70. But it's 1 less because we started at 31. So that's why the answer is 69. So that's another way to think about subtraction. Noah paid $11 for his groceries. He used a $50 bill. While handing Noah the change, the cashier said 11, 12, 13, 14, 15, 20, 30, 50. How much change did Noah receive? Okay, so she counted 1, 2, 3, 4, 5. And then 5. So that was, so he owed $11 for his groceries. So she counted 11. It's weird she counted 11. Oh, he used a $50 bill to pay. So 1, 2, 3, 4. And then we have a 5 difference here. So that's 9. And then we have, oh, it's showing you, so 0. Then 12 is $1, 13 is $1, 14 is $1, 15 is $1, and then 20 is a $5 difference. And then a $10 and then a $20. So this is showing the bills he got. He got a $20 bill, he got a $10 bill, he got a $5 bill, and he got 4 ones. The total amount of change then is $39. This algorithm is very similar to the standard algorithm, except for all the regathering is done before any of the subtraction is carried out. Okay, this is similar to the problem we ended on last time with base 5, but this time it's subtraction. So remember, 5 sets us back to a 10. It sets us back to the 0. So now that's actually like 50, but same idea here. That 5 sent us back to 10. So now this is actually the same as 100. So when I subtract 434 minus 100 in base 5, I get 334 in base 5. And this is using visuals to show a similar idea. Mental mathematics, subtraction, 74 minus 26, you can take away the 20 and then take away the 6. Or here it's showing it, if you don't want to have to borrow in your head, you could add 4, that'd be 78, add 4, just so you're making this 10, so it's easier to see, okay, I can subtract 30 here. 78 minus 30 is 48. And this is showing you if you can drop the zeros. If I have 7,400 minus 600, I can just think about it as 74 minus 660 and then add on the zeros. So those are various subtraction techniques. Hopefully you find that helpful and you can take away some of those ideas for when we teach your students one day.